Okay, so today we're going to go through a circular motion physics problem. The question says, a child sits on a fiberglass mousse fastened 7.4 meters from the center of a merry-go-round platform that is rotating once every 14 seconds. What is the child's speed while sitting on the mousse? What is the kid's acceleration while sitting on the mousse? And what is the child's acceleration if he moves to the rubber bison fastened 5.2 meters away from the center? So what I went ahead and did is wrote out what we are given from this problem. So we are told that from the center of the merry-go-round to where the mousse is a distance of 7.4 meters. That's going to be a radius, and I also drew it out here, a radius of 7.4 meters because we know obviously merry-go-rounds are centered circles. We're also given the radius in part 3 of the question of where the bison sits on the merry-go-round, and we're told that it takes 14 seconds for the merry-go-round to make one full circle. So, solve the problem from here. We put our givens at the top. I went ahead of time and wrote out a formula sheet. So to solve this first part of the problem, we need to find the circumference of the radius of the mousse. The reason we're doing this is because to find the speed, which is our first part of the problem, we need the distance. Well, the distance from this point where the mousse sits on the merry-go-round and travels that whole 14 seconds is the circumference of a circle. So to find the circumference first, we're going to take this formula right here, C equals 2 pi, and then we're going to multiply it for our radius of the mousse, which is 7.4 meters. This equals 46.5 meters. Now we also know that while this is the circumference, it's also our distance all the way around. So to get the speed, which is the main part the problem is asking for, we're going to use this formula right here and solve for this distance over the time t it takes for the mousse to make a full lap. So this is 46.5 meters over 14 seconds equals 3.321 meters per second. This is the time, or not the time, this is the velocity and speed of the kid sitting on the mousse. So part 2 of the problem asks us to find the acceleration of the kid on the mousse. To find the acceleration, we're going to use this formula right here, which is centripetal acceleration. So we already have the velocity. We just found it right here. And we actually have our radius. So all we have to do is plug in our numbers into this formula. So acceleration equals 3.321 meters per second squared over our radius, which is 7.4 meters, equals 1.491 meters per second squared. And we know that this ends up being meters per second squared because if we just ignore the numbers right here for acceleration in this formula, we're taking the velocity. So we have meters per second squared over meters. Well, when you simplify this down, you get meters squared over seconds squared over meters. This cancels, and you're left with meters per second squared. So, part 3 of the problem asks us to find the acceleration on the bison. Well, we know that the radius of the bison is 5.2 meters away from the center of the merry-go-round. That is different from the radius of the moose, so we have to solve for the circumference and speed like we did with parts 1 and 2 to get the acceleration. So we're going to take the circumference problem formula equals 2 pi times 5.2 meters. And I'll put over here that circumference also equals distance to make it a little clearer. So we have 2 pi times 5.2 meters equals 32.673 meters. Now, to get the speed, looking at our formula sheet over here, speed is distance over time. Well, the position of the bison and the moose on the merry-go-round does change from the radius, but the time it takes for this bison right here to make one full lap is still the same. So we have 32.673 meters over 14 seconds equals 2.334 meters per second. And now to find the acceleration, we all just have to plug it into the centripetal acceleration formula, which is acceleration equals velocity, which is our speed here, 2.334 meters per second, squared over the radius. And we're going to use the radius of the bison, 5.2 meters, equals 1.047 meters per second squared. And that's how you solve all 3 parts of this problem.